All right, this is MCT4C, day 38, the first day of Unit 5, which is on polynomial functions. It's a fairly long unit, so we're going to strap ourselves in for a long but smooth ride. Uh, Recognize polynomial functions. So this is sort of straight off what we're after. And in this table, we've got examples of polynomial functions and non-polynomial functions. And the non-functions, we talked about what makes a function, or sorry, a relation, called a relation, not a function. So these things are all non-functions. And we're not really talking about that, although you'll be asked um, that sort of thing in the homework. Notice what makes not a function. It's anytime it doesn't pass the vertical line test. Squares on the y is a good idea, or this idea x equals -2 is a straight line, straight vertical line. But this is what we really are interested in. These are functions, but not polynomial functions, and these are polynomial functions. So what we're asked to do is write a few ways to identify if a given relationship is not a polynomial function. So what did we notice in here? And I wrote a bunch of stuff down, hopefully so did you. Well, if the x is in the exponent, or we have a square root of x, like in these two, this makes it not a polynomial function. The unknown's in the exponent, or the unknown's underneath the square root. Get some trig. Now that's a trig graph. It looks like cosine. That's not polynomial. Negative exponents on the x, so that's not allowed. That looks pretty much like some of this other stuff that's over there, but it's a negative exponent on the x, that's not allowed. If the unknown, the x, is in the denominator, that's not allowed. So all these things make them not polynomial functions. Well, then what's left over? Well, what do we notice about these? Well, there's a bunch of pieces, and the pieces kind of look the same, but what characteristics they have? The pieces we call terms, so there's a bunch of terms. The real number coefficient, so the number in front of the x part can be a fraction, it can be a decimal, it can actually even be a square root as long as the x isn't underneath there. But the number part, the coefficients, can be any real number. And the exponents are whole numbers. So the exponents on the x can't be negative, whole numbers only. Whole numbers are, 0, 1, 2, and so on. And then in the lesson here, we have an example almost straight off. There's a definition. A polynomial is a mathematical expression with one or more terms in which the exponents are whole numbers and the coefficients are real numbers. Okay. Notice this is a mathematical expression. And before we were talking about polynomial functions and expressions. Well, what's the difference between a function and an expression? Well, we'll get to that in a second. But for right now, let's just talk about an example so we can get some of this terminology out of the way. So I'm going to write down an example of a polynomial, and this is going to be a polynomial. So what are some things that we see here? Well, the number parts are coefficients, right? And they're real numbers. All the number parts. We see that the exponents are all whole numbers, right? The exponents are whole numbers. And this one is implied to be a 1. They're all whole numbers. And what's the exponent on the variable here? Well, we could consider this x to the exponent 0, but 0 is also a whole number, and we don't write that in there usually. X to the exponent 0 is just 1 anyway, so we usually leave it out. This term actually has a special name. It's called a constant. It has a constant because it doesn't change with x. That kind of makes sense. These pieces, and we kind of see these pieces here. This has got, there's one piece, there's another piece, minus sign in there too, and then finally there's 4 of these pieces are called terms. That's 4 terms. And so this is a polynomial expression with 4 terms. Before I talk more about terms, there's one other thing that I kind of failed to mention, and that's this idea of this number here, this coefficient has a special name. It's called the leading coefficient. The leading coefficient is special because it's connected to the highest power of the variable x here. So it's the leading coefficient. Back to this terms business. Altogether, these expressions are called polynomials, but we have special names for a one-term polynomial is called a monomial. Mono means one, like monopoly, right, or monorail. A 2-term polynomial is called a binomial, like bicycle, right? And a 3-term polynomial is called a trinomial. And there's probably names for the other ones there, but that's as far as we're going to go. Okay, now this business, degree of a term. The degree of a term is the exponent. It's got to do with the exponent. So it's actually the total of all the exponents in a term. So let me give you an example. So for instance, the degree of this term is just 3 because it's the sum of the exponents. Well, it's just an exponent 3. But if I had this term, this is just the term. It's got 2 variables in it, but what degree is it? Well, 2 and 3 is 5. This is degree 5, this term. And usually when we write polynomial expressions, we're writing them in degree that's going down. So the highest degree and then the next highest and so on. The degree of a polynomial function, so this is a degree of a term. The degree of a polynomial function or a polynomial expression is the highest single term degree. So I kind of look back at my polynomial expression, and while this term has degree 3, this term has degree 2, this term has degree 1, this term has degree 0, but altogether, what degree is the polynomial expression? Well, it's the highest term one. So this polynomial is of degree 3. So, for example, the earlier example is degree 3. Okay, here's this idea of this, we've gone back and forth between functions and expressions. There's also equations. What's some stuff we can do? Well, here we go. Let's check the time here. I'm going to stop there and do the second part in the second half of the video, okay, folks? It's not going to be long, but it's worth stopping for.